We want to look at FSC 114 topics, just to use it to engage the 100 level students. I will advise you follow up with my class. This is the first of the class, and today we are going to be looking at complex number. Complex number. Complex number is one of the topics that you are going to be doing. Some of you guys have done it, while some other group might not have done it. Either you have done it before, you have not done it. It's an opportunity for you to learn more of it. Now, recall, in our secondary school, we did what is called quadratic equation. In our secondary school, we did quadratic equation, and we said when we have ax squared plus bx plus c equals to 0, where a is never equals to 0, we said this is quadratic equation, if you can recall. And we said this quadratic equation, we have 4 different methods of solving it. One of the methods is factorization method. We all know that. We have factorization method to solve quadratic equation. The other one, we have completing the square method. Completing the square method. Completing the square method. The third one, we have what is called quadratic formula. Quadratic formula. Some people call it almighty formula because you can solve any kinds of quadratic formula. While the last one, quadratic can also be solved with graphical method. We call it graphical method. These are the 4 methods of solving quadratic equation. Either of the method, you are going to have the same result or the same root. The solution to this quadratic equation is what is called the root of equation. And out of this, the most general of the method is quadratic formula, which says if I have x, the root of the equation will be x equals minus b plus or minus square root of what? B squared minus 4ac divided by 2a. This is quadratic formula. This formula can solve any type of quadratic equation. Now, if you can also recall in our secondary school that before that, let me just say this. All these things that I have inside the square root bracket, let me call it d. Let's say my d is equals to b squared minus 4ac. Now, from here, we can say x is equals to minus b plus or minus square root of what? D divided by 2a. Now, in our secondary school, we only study 2 solutions of this kind. The first one is if my d is greater than 0. If my d is greater than 0, it means it is very easy for me to find the square root. Then we are going to say we have what? 2 distinct roots of the equation. That is, I'm going to have x1 and x2 at distinct roots. Remember, this one will give me 2, let me just say 2 distinct roots. That is it. The other one we also study in our secondary school is also when d is equals to 0. Then this one will give me equal roots. Our second, okay. But in our secondary school or at our secondary school level, we do not consider a case where your d is negative. If my d is less than 0, it means my d is what? Negative. Then this one will not give me a direct solution. And this is what brings about what? Complex number. This, when d is less than 0, then I'm going to have what is called complex root. Yes, I'm going to have what is called complex root, and that is what brings about what we want to study today. Now let's see the complex root. Now we want to see in a case where we have an equation that is not what? That will not give you real root. Then we are going to have what is called what? Complex root. Let's look at Example, let's assume I have my d to the negative, that is my x equals minus b plus or minus square root of minus d. Then it is not easy to divide by 2a. It is not easy for us to find the square root of minus d. Yes, because if you press your calculator, it's going to give you errors, meaning you cannot find square root of minus d. Then you can simplify your minus square root of minus d. Remember, if I have square root of ab, I can write it as well, square root of a times square root of b. If I apply the same procedure, then I can say square root of minus d can be written as well, square root of minus 1 times square root of what? D. Then this square root of minus 1 is what brings about to the complex plane. And this is what is called, then if I substitute that, I'm going to have x equals minus b plus or minus square root of minus 1 times square root of d over what? Over 2a. Where this square root of minus 1 is what is called my I. Square root of minus 1 is equals to what? I. Then I can write this as what? X is equals to minus b plus or minus I square root of what? D divided by what? 2a. This is now what is called complex number. I can split this complex number into two parts, or this my solution, I can split it into two parts. That is, I can write it as x is equals to minus b over 2a plus or minus I square root of d divided by 2a. Where this part is what is called the real part, and this is what is called what? Imaginary part. Imaginary part. It means a complex number is going to have two parts, the real part and the what? And the imaginary part. Also, as well know that all numbers in maths, we can perform different operations. We have integer, we can add two integer, we can subtract two integer, we can multiply. The same thing to complex number. We can also perform different operation in complex plane or complex number. Let's see. Let's look at the next thing is we want to look at operations in complex number. We want to look at operation complex number. Let's see. Operation in complex number. Let Z1, if my Z1, that is the first complex number, let's say is equals to x1 plus I y1, comma Z2 equals x2 plus I y2, Z3 equals x3 plus I y3. Now let's look at the operation. The first operation we want to look at is addition. Addition, the first one, Z1 plus Z2 will be equals to, my Z1 is x1 plus I y1 plus x2 plus I y2. Now if you are adding complex numbers together, you are going to add real with real and what? Imaginary with imaginary. The same thing to if you are subtracting. Let me just put plus or minus. Yes, let me put plus so that I will not need to do the negative side. Now at the end of the day, this will give me Z1 plus or minus Z2 will now give me, since I want to combine the real with real, my real, the first real here is x1, the second real, then I'm going to have what? X1 plus or minus y1 plus I y1 plus or minus y2. That is the first solution. That is, let's look at example to showcase this. Example. Let's say if I ask you, if z equals 3 plus 2i, if z1 equals 3 plus 2i, and z2 equals 5 minus 7i, find z1 plus z2. What does it mean to add z1 and z2? Solution. You will see that what is my z1 plus z2 will just be 1. What is my z1? 3 plus 2i plus 5 minus 7i. As I said, we are going to add real with real. That is 3 plus 5 plus imaginary with imaginary. We have what? Plus I 2 minus 7. This is minus because it's plus minus 7. Then the minus will affect the plus, then it return. Then the solution will now be what? Z1 plus Z2 will now be equals to what? 8 minus 5i. That is how to add two complex numbers together. Let's look at multiplication. Now, before we go to multiplication, I want to say this. Addition of complex number is commutative. What does it mean? That is, if I say z1 plus z2 is also the same as saying what? Z2 plus what? Z1. This property is what is called what? Commutative property. Properties or property is commutative. That is, either you bring Z2 first or Z1 second, you still have the same result. You can check that. That is, just say 5 minus 7i plus 3 plus 2i. You are still going to have the same result. That is the property of what? Commutativity. Now let's look at, but this does not hold for negative. It does not hold for negative. That is, Z1 minus Z2 is not equals to Z2 minus what? Z1. That is, the commutative property does not hold for what? For subtraction or for negative. Now let's look at the second operation or the third one, which is multiplication. Multiplication. That is, we want to look at Z1 times Z2. We want to multiply Z1 and Z2. At the end of the day, we are going to have, what is my Z1? X1 plus Y1, IY1 times X2 plus IY2. Now, let me expand. Whenever you have this multiplying themselves, you are going to what? Expand. You use the first X1 to open up this bracket, then plus you use the second, the Y1, IY1 to open the second bracket. Now, Z1 times Z2 give me Z1, Z2 plus I, X1, sorry, is X, Y2 plus I, S2, Y1 plus I square, Y1, Y2. At the end of the day, I have Z1, Z2 to be equals to X1, X2. Now, let's see, before we even comply, I'm supposed to have tell you one or two things before this, but let me just say this. Before we continue from this, let's look at this. Before we continue the product, let me show you first thing. Now, we said square root of minus 1 is equals to I. Then, if I now have I square, what does it mean? I square means what? Square root of minus 1 times square root of what? Minus 1. Whenever you are multiplying square root of two things, if the same, it has the same number, it has the same radical, then the answer will be the radical. That is, square root of minus 1 times square root of minus 1 will give me minus 1. Just take note of that. Also, I raised to power 3. If I want to get I raised to power 3, still follow the same logic. I can split this I raised to power 3 as what? I square times I. From law of indices, I can split that. Then at the end of the day, since I know my I square to be minus 1, I can say what? Minus 1 times I. At the end of the day, I have what? Minus I. How about I raised to power 4? I raised to power 4 will give me what? I square times I square. Law of indices, I'm going to get that. What is my I square? Minus 1 times minus 1. And what is that? Is equals to 1. With this definition, with this 4 definition, you can get any power of I. With this 4 definition, you can get any power of I. Now let's look at it. If I ask you to find I raised to power 21, look at it now. I raised to power 21 is very easy. What we are going to do is that since the power is an odd power, just separate it like the way I separate I raised to power 3. Even and odd. That is, I can write this as I raised to power 20 times I. Because at the end of the day, applying law of indices, I'm still going to have I raised to power 21. Now, what is I raised to power 20? Another thing you need to note is that whenever you can divide that even number with 4, then it's going to be 1. But if you cannot divide it with 4, but you can divide it with with 2, then it's going to be what? Minus 1. That is, from here I can say what? I can divide 20 with what? With 4. 4 can go in 20. Then I can write this as I raised to power 4, everything raised to power 5 times I. And at the end of the day, since I raised to power 4 is 1, and anything raised to power of 1 is still 1, then I have what? 1 times I, meaning this is I. If I ask you to find I raised to power your date of birth, you should be able to do it. That's it. Let's look at this. If someone is born 2019, then I can say what? I raised to power 2019 will give me what? This 2019 is an odd number, then I can split it as what? I raised to power 2018 times I. The question you ask yourself, can you divide 2018 by 4? If you can divide 2018 by 4, then the answer is I. But if you cannot divide 2018 by 4, then it means you can divide it by 2, then the answer will be what? Minus I. Let's see. 2018 divided by 4 it cannot divide by 4. Then it can be divided by 2. Then I can write it as what? I raised to power 2 times everything raised to power 2018 divided by this is what? 1009 times I. And what is this? Minus 1. Then I will have what? Minus 1 raised to power 1019. Oh, sorry, this is 109. This is 109. 1009 times what? Times I. At the end of the day, I'm going to have what? Minus I. In conclusion, when you can divide that number by 4, then it's going to give you 1. If you cannot divide it by 4, if it is an even number, you cannot divide it by 4, then it's going to give you what? Minus 1. Also, if it is an odd number and you can split the even part by, if you can split it even and odd, then you consider the even, then you multiply it by what? By I. That's just the way on how to do. You can try your date of birth or other things about this. Now, let's now go back to what we are doing. From that knowledge, you can see now, it means by Z1, Z2 will now be equals to what? We have X1, X2 plus, look at it now, this I square is what? Minus 1. It means this part will now turn to what? Real part. There won't be that I again. Then I can combine with X1 and X2. Then I can write it as what? Minus Y1, Y2 plus, since I have two imaginary parts, I can bring out the I, and I say what? X1, Y2 plus S2, Y1. And that is what? The way to multiply complex number. Even if you have Z1, Z2, Z3, it's still the same thing. This your result, just multiply it again with Z3. You still have the same, you have a reasonable answer. Now, another property that we need to take note of is what is called, is also commutative property. Z1, Z2 is equals to Z2, Z1. This is also what? Commutative property for product. The other one is for addition, but this one is for multiplication. Sorry, it's for multiplication property. Properties. That is, if I have Z1, Z2, Z3, continue. You can split it anyhow. That is, I can have Z3, Z2, Z1. They are what? They are commutative. That is another operation of complex number. Now let's now look at also division. Now another property that I want to look at is division. Division of complex number. If I have Z1 divided by Z2, this is the third one. That is x1 plus iy1 divided by x2 plus iy2. Now, if you want to divide complex number, we need to go back to the knowledge of surd in your secondary school. When you have a surd at the denominator, we usually use what is called conjugate rationalization. Yes, we are going to rationalize by multiplying what? Both your numerator and denominator by the conjugate of the denominator. The same thing to this. I'm going to multiply both my numerator and my denominator by what? By the conjugate of the what? Of the complex number. Now let's look at conjugate before we solve this question. When you have a complex number, let's say Z1 is equals to x1 plus iy1. The conjugate of this, the conjugate of Z1. Let's define, we can define, let's say which define is defined, is defined as, let's say, Z1 star. Z1 star. If this is a conjugate, then it's defined as what? Z1 star will just be what? X1 minus iy1. That is, the sign of the what? Imaginary part of your complex number is going to change. Take note, the sign of your what? Your imaginary part of the complex number is going to change. Now, let's look at the example. If I have this complex number, let's say I gave you 3 minus 5i. If I ask you to find the conjugate of this complex number, it's going to be what? If this is z, the conjugate of this will be what? Z star. You can just say it's what? 3 plus 5i. This is another way of writing complex number. Your I can come first, or you can come at the back of the what? Of the number. This is the conjugate. That is, the sign of the what? The imaginary part is going to change. Now, what if I gave you something like this? Z equals 2. What is conjugate of Z? Some people usually get this thing wrong. They will say minus 2. It's not true. You can just write this as well. Z is equals to 2 plus I0. Then the conjugate of 2 plus I0 will give you what? 2 minus I0, which is also the same as well, 2. It means when you have the real numbers alone, the conjugate of that real number is still the what? The same real number. Take note. Now, let's now apply this to this division. If I have this, I want to divide it now. Z1 divided by Z2. Now, let's see. Z1 divided by Z2, which we have defined as x1 plus iy1 divided by x2 plus iy2. Now, what is the conjugate of this denominator, class? The conjugate of this denominator will be what? x2 minus what? iy2. Then I will use it to multiply times s2 minus iy2 divided by s2 minus iy2. Then let's now divide it. We have z1 divided by z2 will now be equals. Now we have length product, that is x1 plus I y1 s2 minus I y2 s2 plus I y2 x2 minus I y2. We have length product, so yeah, let's multiply them. Denominator, I have x1 x2 minus I x1 y2 plus x2 y1, this is I. Now minus I square y1 y2 divided by, let's do the same thing to denominator. We have s2 square minus I s2 y2 plus I s2 y2 minus I square y2 square. At the end of the day, let's see. From what we learned the other time, my I square will turn to minus. Then minus times minus will turn to what? To plus. Then it will make this part to be what? To be real part. Then I can combine the real part. I will now have what? x1, x2 plus, because my I square will be minus 1. Minus 1 times minus will give me plus. Then I have y1, y2 plus. Now, these are imaginary. I can bring out the I. If I bring out the I, then I must bring out the one that is positive first, because I'm having plus I. Then I have what? S2 y1 minus x1 y2 divided by. Now, this one can cancel this. Then I have what? X2 square plus I square is also minus 1. Minus times minus is plus y2 square. And this is how to what? To divide a complex number. Very easy. But let me just give you one logic. Your denominator always be difference of 2 square. Whenever you are multiplying by a conjugate, you don't need to multiply your numerator again. Just square the two numbers, then you have your answer. You add it together. That is your what? Your denominator. Because it's going to give you the difference of 2 square. That is the operation of what? Of complex number. Another thing that you need to take note of, your addition is also associative. Your product is also what? Associative. But your what? Your subtraction is not commutative, is not associative. Likewise, your division is not associative and is not what? It is not commutative. Now, let's now go to the application of all this jargon. We are doing example. Let's look at example. Simplify. 2 minus 3i divided by 5i plus 3 divided by, let's say, 3 minus plus I. I want to simplify this. Now, solution. You can do this question in 2 ways. Since this is a what? A fraction in complex number, you can do it in 2 ways. You can solve each part separately, then you add the answer, or you combine the two by finding what? The LCM. Any of the two, they are correct. If you want to find the, since this denominator is division, and we have done division of complex number, then you can apply it. You apply the division of it to the, that is by multiplying by what? The conjugate. You rationalize the denominator, then you add the result, or you find the LCM of everything. Any of the two, you get the same answer. Now, solution. Let me rationalize. I think that will be very easy for me and more direct. If I rationalize this part, I have what? 2 minus 3i divided by 5i. Now, for me to rationalize, anytime you are having a question of complex number, denominator must not have I. You must not have the what? An I as your denominator. If you have I as your denominator, then you must what? Rationalize. The same thing when you have a sub root in your denominator, you are going to what? Rationalize. Now if I want to rationalize this part, I will also multiply by what? 5i divided by what? 5i for this part, plus 3 divided by 3 plus I. Now this one I'm going to rationalize with what? Conjugate of the denominator, that is, and what is conjugate? 3 minus I divided by what? 3 minus I. Then if I do that, I have 5 times this, I have 10i minus I square 15, or 15i square, divided by 25i square, plus, now the same thing, 3 times 3, 9 minus 3i, divided by, like what I said, difference of 2 square, just write it as well, 3 square plus 1 square. Or you can multiply it and open the bracket yourself. At the end of the day, I have this is 10i, I square is minus times minus plus 15, divided by, I square is minus, I have minus 25, plus 9 minus 3i, divided by, this one will give me what? 9 plus 1. At the end of the day, I want to take the minus up. I will have minus 15 plus 10i divided by 25 plus 9 minus 3i. Now, from here, I can take the negative. Okay, this side, I can easily factorize out 5. From here, if I factorize out 5, I have 5 into, this will give me 2i plus 3 divided by minus 25, or I can take the minus up, plus 9 minus 3i divided by 10. At the end of the day, this will turn to minus 2i plus 3 divided by 5 plus 9 minus 3i divided by 10. Then from here, I can easily find the what? The LCM of the denominator and combine. The LCM is 10. 5 in 10 is 2. I have minus 2 into 2i plus 3 plus 9 minus 3i. And if I open this bracket, I have minus 4i minus 6 plus 9 minus 3i over 10. At the end of the day, we have 3 minus 7i over 10 is the solution to the given question. If you look at this question, we have combined different operations. We combine addition, subtraction, multiplication. That is how to handle question of operation of number, complex number. It is very, very simple. Just follow the procedure. Now, we want to move directly to the next thing, which is representation of complex number. Representation of complex number, that is the next thing we want to look at. Representation of complex number. Complex number can be represented in 3 ways. Complex number can be represented in 3 ways. The first one is what is called rectangular representation. Rectangular, or we call it Cartesian. You can also call it Cartesian representation. Cartesian form, rectangular form or Cartesian form. That is the first one. The second one, we have what is called polar form. And the third one, we have what is called exponential form. Exponential form of the complex number. Exponential form. We are going to look at these 3 forms of complex number. The first one we see is what is called the Cartesian and the rectangular. That is the one that we have z equals a plus or x plus iy. This form of complex number is what is called rectangular and Cartesian form, and that is the natural form of the complex number. Is the natural form. That is from the derivation, this is what we get, and this form is called the Cartesian form and also rectangular form. And we can interpret this on a diagram. If this is my diagram, this is my diagram. We have the vertical component and the horizontal component. My vertical component is my y, and this horizontal component is my x. Now, you remember in our physics, I can say what? I can find the resultants of this. Now, this resultants is what is called your z, the complex. This is my z. And there is an angle, or let me call this r, don't let me use z, let me call it r, the resultants of the what? Of the plane. And there is an angle inclined by the two what? By the two value. Then this is your what? The interpretation of your what? Your rectangular form, the Cartesian form of the complex number. Now, from this now, remember, we want to now look at how to move from rectangular form or the Cartesian form to polar form. Remember, from this diagram, from this Cartesian diagram, we know that the resultants are from Pythagoras theorem. Remember Pythagoras theorem, because this is like a triangle. This is like a right angle triangle. This is angle 90. It means my r is the hypotenuse. And this can also be, this is my x. And this is my y. From Pythagoras theorem. Remember, Pythagoras theorem says what? You can write from Pythagoras theorem. Says what? The square of the hypotenuse, which is what? Your r square equals x square plus y square. And this can be written as r is what? Square root of what? X square plus what? Y square. Also remember that we can also find theta. Theta is always be what? Remember from SOHCAHTOA. Since you know your r, theta, you can find theta in form of what? The angle or the trig identity, that is sine, cosine, depends. I can say theta can be written in form of, if I want to find sine, I can say what? Sine theta equals, which is what? Opposite over what? Hypotenuse. My opposite is y because theta is facing y. We have y over hypotenuse is my r. Then I can say from here that my y is what? R sine theta. That is sine theta. If I want to find cos theta is what? Car adjacent over what? Hypotenuse, which is what? X over r. And I can say my x is equals to what? R cos theta. Then it means from here, I can substitute my x and my y into the what? The rectangular form of the complex number. If I do that, it means my z can be written as, my z will now be what? Put x and y. I'm going to have r cos theta plus I r sine theta. From here, I can factorize out r. Then I have r into what? Cos theta plus what? I sine what? Sine theta. This form of complex number is what is called the polar form of the complex number. Look at the way we prove it. We move from the rectangular form to what? To a polar form. Very simple to prove. It means when you are given a question in rectangular form, you can easily convert it to what? To polar form. Now let's look at the third form, which is what? Exponential form. Now, exponential form of complex number is also defined as, it can be proved, but for your level, I don't want to complicate something. This e raised to power, remember, e raised to power x. I'm very sure this will pass your level, but let me just say it. E raised to power x is defined as 1 plus x plus s squared plus s raised to power 3, continue like that. That is the expansion of what? Exponential x. Also, e raised to power ix, it has a meaning. It's the same of saying cos x plus I sin x. Because if you put x, listen, if you put anywhere you see x here, if you substitute ix to it, you are going to have both imaginary and the real part. Then if you factorize out it, you will see that it's going to give you there. It means I can say what? E raised to power I theta is same as saying what? Cos theta plus what? I sin theta. Then it means I can remove all this. I can remove cos theta plus I sin theta. I will now say my z is equals to r e raised to power what? I theta. This is the exponential form of the complex number. It's the exponential form of the complex number. I can show this, but for your level, I don't want to bother you. You can use Taylor series expansion to get this, but I don't want to bother you for your level. Later on in maths, you will learn on how to show those things. Now, that is the forms of complex number. It means if you are given a question in polar form, I can leave my answer in exponential form. You should not find it very difficult. Just know how to manipulate from one form to another form. Another thing that I want to look at, which is also very important, but before that, let me give you one question to show if you really understand what we do. Let's solve one question. Let's see before we move to the next. Now, example, another example. Convert z equals x plus iy to polar form. This is very easy. Now, to convert to polar form, I need two things. The first thing I need to get is my r. Also, I also need what? Theta. If you know those two things, then you get your polar form. Now, you recall that my r is what? Square root of what? S squared plus what? Y squared. And what is S squared? What is S squared? S squared is 1. What is x? X is y. Since my r is what? 1 squared plus 1 squared, which is equals to what? Root 2. That is my r. Now, I want to get my theta. You can get your theta in two different ways. You can just sketch the diagram. Give this as your 1. This is also your 1. Then I can just join. We have calculated this to be root 2. This is my theta. This place is also 1. Let me just say this is 1. I want to get my theta. You can use any of the Pythagoras theorem. Now, if I use sine, I will say what? Sine theta equals what? 1 over root 2. That is, my opposite is 1 and my hypotenuse is what? Root 2. And what is that? Theta will just be what? Sine inverse of what? 1 over root 2. I think this will give me what? 30 degrees. Then I can easily go back to the formula of what? The polar form, which says what? Z equals r into what? Cos theta plus what? I sin theta. Or you can do that, or in another form, since you know your sin theta, from here I can find cos theta. I will not just bother myself. If I want to get cos theta from here also, cos theta is what? Adjacent over what? Hypotenuse, which is still the same thing. 1 over my adjacent. This is also 1. My adjacent is also 1 over root 2. And what is that? 60. But theta from here is 60. But I don't even need that. Just substitute sin theta and cos theta. Then I can say what? My z is equals to, my r is root 2 into, what is my sin theta? 1 over root 2 plus I 1 over root 2. If you open the bracket, Okay, sorry, I said you should leave your answer in polar form. I'm going back to rectangular form. I will just leave my answer there. I will have z equals root 2 into what? Cos what? Cos my theta is 30, abi, from here. My theta is cos 30 plus what? I sin 30. Since my theta is what? Is 30 from here. That is just on the rectangular form. Now, another thing we want to look at now is how to multiply. You know, we multiply rectangular form or Cartesian form. We can also do the same thing to other form, the polar form and also the exponential form. Also, those properties that I showed you the other time, commutative property, associative property, they also hold in other form also. The polar form is also associative, the product, the multiplication and the addition. The same thing to exponential. But let's look at the polar form and look at those properties. If I have z1, let's see the product of polar form. If I have z1 to be equals to, let's say z1 is equals to r1 into cos theta 1 plus I sin theta 1. And I have z2 to be equals to r2 into what? Cos theta 2 plus I sin what? Theta 2. z3 equals r3 cos theta 3 plus I sin theta 3. Now, the same thing, we want to find the product of this. If I have z1 multiplied by z2, what am I going to get? Let's see this. What does it mean? z1 multiplied by z2, I have what? r1 into cos theta 1 plus I sin theta 1 times r2 into what? Cos theta 2 plus what? I sin what? Theta 2. I want to multiply it. Now it means my z1, z2 will just be what? r1 times r2 will give me what? r1, r2. Then I want to multiply what? Cos theta 1 plus I sin what? Theta 1 and cos theta 2 plus I sin what? Theta 2. At the end of the day, I have what? z1, z2, r1, r2 now be equals, let's multiply. Cos theta 1 times cos theta 2 give me cos theta 1 cos theta 2 plus I cos theta 1 sin theta 2 plus I cos theta 2 sin theta 1 plus I square sin theta 1 sin theta 2. Okay, let's continue. From here, we can see that what? r1, r2 will now give me what? This is cos theta 1 cos theta 2 plus, now I want to combine the same thing I did the other time, real with real. Since I have I square here, it will turn into a real part. Then what is I square? Minus. I will turn this will turn to what? Minus sin theta 1 sin theta 2. Then I can write this as what? Minus sin theta 1 sin theta 2 plus I. Then I have what? Cos theta 1 sin theta 2 plus cos theta 2 sin theta 1. Now, remember from trigonometry identity, trig identity, let me give you some trig property. Remember, sin A plus B equals sin A cos B plus sin B cos A. Also, I can say what? Sin A minus B is same sin A cos B minus sine B cos A plus B equals cos A cos B minus sine A sine B cos A minus B equals cos A cos B plus sine A sine B. This property is very, very important. That is what we are going to apply. If my A is equals to theta 1 and my B is equals to theta 2, then I can say what? Z1, Z2 will now be what? R1, R2 into cos theta 1 cos theta 2 minus sin theta 1 will give me what? It's going to give me cos theta 1 plus theta 2 plus I. This will also give me what? Sin theta 1 plus theta 2. And that is how to multiply the polar form of the complex number. That is how to multiply the polar form of the complex number. Now, even from here, if I multiply my Z2, Z1 also, it's going to give me the same thing. If I multiply Z1, Z2, I'm still going to have the same thing as R2, R1, which is still the same thing, which is still cos theta 2 plus theta 1 plus I sine theta 2 plus theta 1, which is still the same thing. From here, I will see that what? Z1, Z2 equals Z2, Z1, which is the property that I gave you the other time, associative property. What if I'm multiplying 3? If it is 3, it's still the same thing. We can show it. Z1, Z2, Z3 is going to give me what? R1, R2, R3 into cos theta 1 plus theta 2 plus theta 3 plus I sine theta 1 plus theta 2 plus theta 3. If I'm multiplying 100, it will still give me the same thing. From here, we can just conclude that what? From here, we can say what? Z1, Z2 to Z3 continue to Zn. Then it's also going to give you to theta or to N10. Now, that is how to multiply polar form of the complex number. Now, I want to move to an interesting area now, and that is where questions usually come out in your exam. You need to take notes.